File system handling. Right? What are we really talking about? First of all, let's understand that part. See, while work, let's understand from our work purpose itself. Let's say I'm trying to design an automation framework, and I have my test data written, let's say in an Excel sheet, in a text file, right, in a Word document, or maybe some other thing, right. I have a document, right, where my test data is deciding, and I need to read that data from that source, and I need to consume it in my project, right, in my automation framework. So the ask is very simple, right? We have a framework. We have a framework where it requires, and we have a test data source, which let's say is an Excel or a text file or whatever it is, right? It is placed there. And this is our test data source. Test data source, right? And we need to read the data from it, right? In our framework. That is the part. A simple task, right? It's a file, but it is something external, or maybe, I mean, it's a different entity altogether, right? A file. Okay. Now, if you have to interact with this file, right? Let's understand from the OS perspective again. Yesterday also we understood from the OS perspective, like how threading is there, right? Similarly, let's try to understand how, if you store a file in your system, right? What does it really happen? Okay, what really is happening behind the scenes? See, you have an OS, right? Operating system. Okay, you have an OS, right? Let's say OS, right? Now, let's say you wanted to, you have a file and you want to read it, right? So you OS again will take your commands, right, with request, with the, like, let's say by the way of click and all, right? It will try to understand, okay, what you're trying to do. Let's say you found the file and you double click on it, right? What will happen is, inside every operating system you have a file system. Inside the OS you have a file system, and there is a name, right? If you would search for Mac machine, it is different. For Linux, it is different. For Windows, it is different, right? And for other OS, it would be different. Okay. If I give you the name, okay, but it does not matter. But okay, let's not go in that direction. It does not matter, right? But you have to understand there is a file system involved, right? Which 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 manages everything with respect to your files. Okay, files and directory. Okay, so every request has to go through this file system, right? This is the one which manages all your files inside the OS. Okay, so this is one thing, right? Again, this you can understand is like a piece of software or something, right? Which is inside your OS, which will manage everything. Okay, fine. Now, let's say, where does that, let's say you have a file, right? Where does it get stored? You have to, I mean, okay, again, let's not, I don't want to go into too much deep. I think it does not fit for all. So what, let's do one thing. What happens is, let's say this file system, right? If I ask you to store a file, where does it file store? In your hard disk, right? That is where the file gets stored. So you have a hard disk. Okay, you have a hard disk where somewhere the file will be stored, right? A file will be stored. Okay, now it's a disk, right? Now if we go inside this disk terminology, right? There are different terminologies. There are data partition, right? Data partition. There are blocks, right? There are what we say, this data partition, this is block, right? And this has to be like the disk slot, right? And all that. So there are different terminology, right? Inside a hard disk, right? Whenever you are placing an item, wherever it is stored, right? It, and tomorrow if you want to read back, right? You need to know, like, which part inside, which section inside your hard disk is storing all that, right? How would you know that, right? How would you know that? The file system will help you to know all of that. Okay, so this is the responsibility of file system, which manages, like, where that file is. So all the metadata information about the file is maintained here, right, in the file system. Okay, metadata about your file, the actual file is here in the hard disk, right? But the metadata about your file resides here, about your file, right? Now one more thing, like, there is like, if you have to write into a file, right? you have an you have a concept of input output operations, right? Which is managed by OS, right? Which is managed by the operating system, right? If you have to, let's say, provide, you have to write, right? You have to write the file. I mean, let's say you want to update the file. What is required is, you need to find at which location of your hard disk the file is, which disk partition the the file is placed, what is stored inside this, right? And all the other terminologies. So you need to find the like the complete address of that file, right? And on top of it, you need to know, okay, your file already has, let's say, 6 lines, and you need to start from the 7th line, right? Let's say if you have to write, right? So you're doing the operation, right? And whenever you are writing something, right, it means some new data is flowing in, right? Some new data is flowing in, right? And how the disk, right, the input output operations performs on the disk is they write, right? They will write the operations, right, on the disk. So it is it is a very expensive operation, right? Try to understand. You are, whenever you write to a file, right, whenever you are writing to a file or reading from a file, you are utilizing your resources, your compute resources, to do that operation, right? And if you do it once, right, and you grab everything, then it's a good thing, right? But if you will continue to use your resources, right, just to do this part, right, it becomes an expensive operation, because it requires this input output, right, this operations to be performed, right, for everything which you do with the file. Second of all, the disk, right, the reading from the disk, right, the disk needs to be reloaded and all that, right? So all that operations is required whenever you're trying to work with a file. Okay, so again, these are, everything is happening at the OS level. So you have an operating system. Within the operating system, you have a file system which manages all the metadata about your file. The actual file resides inside your hard disk, right? The address of this file, right, has to be somewhere managed by the file system. And if you have to write something to this file, or maybe read from this file, right, it requires a separate input output operations. Let me show you in the disk task manager. If you can see there, I don't know, you see this disk operation, disk 0, disk 1, right? You see, this is the memory, right? Okay, there is one more concept about memory also. Let me mention that also. So you have RAM. This is a hard disk, right? I think it is called as I don't know what do we call it, but this is, we call it as RAM, right? Random access memory, right? Where you can, I mean, this is like the quick memory, right? Where if it is there, right? If data is there in this memory, right, there is no need to go into the hard disk. I hope we understand this concept, right? We have a RAM thing and we have a hard disk, right? Okay. Now, if we, let's say some data is residing under the RAM, right? Inside the RAM, it is easy to read from the RAM because it does not require you to go to hard disk to read the data, right? You will save some disk operations on it, right? To perform the input output operation on this part, right, this requires the movement of your disk needle. Okay, disk needle, right, to write the operations in that file. Okay, it requires that operation. But whenever you're doing with the RAM, right, if you have some data in the RAM and you want to read it, or let's say you have something stored in the RAM and you will try to write to it, right, it does not require that thing, right, because you're not writing in the disk, you are just writing in the RAM. And then in the end you can just store everything together in the hard disk. Okay, but this will be a quick operation, and this will be a very, it will be a lengthy operation, because every time you will have to involve that disk needle operations, right, which is the input output operation. So what I am saying is, so these are 5 different things why we learned about this. I'm coming to this part now, right? uh, First of all, you can see, right, anything you do with your system, right, requires some CPU power. First of all, right, if I will start writing in the file, CPU power is required. Second of all, memory also, right, RAM. Let's say you read the data from the hard disk, right, and let's say you want to keep the data in the RAM. You can see, right, I have a RAM size of 7.9 GB. Okay, so it's not like, and my hard disk is around, let's say, 1 TB, right? So 8 GB and 1 TB, no match, right? So it's not that you can keep everything inside the RAM. No, right? Everything has to be in the hard disk only. But it's said that for the quick traversal of the information, you're doing such an operation and it requires some quick operations, right? So in that case, you can keep the data in the memory, so that you can reduce your traversal time, right? Okay, now the disk side, right, you can see currently I'm not writing anything, I'm not doing anything. My disk is okay. Once I start doing something, right, making use of the disk to write some operations or read the operations from it, you can see it will, the resources put on the disk, right, will get, you see 0% there, right, it will increase. Okay, and if it gets utilized, right, you are left with less thing to, I mean, less power on it. Okay. Okay, I hope this is making some sense, right? Now let's try to understand. Okay, why did we had to learn all this in Java, right? In Java. So this is about the OS level, like how things happen. Okay, let me just again repeat myself. Let's say you want to do a read operation, right? Let's say you want to do a read operation. What you can do is, the one of the possible case, you will ask your OS, okay, please open this file. You will double click on it. It will file in the file system. It will get the, it will find the your file info, right? And then it will go to the hard disk. Once the hard disk, it find the file, right? Let's say it loads that file in the RAM. All the data is loaded into the RAM, right? So this is the first step. This is the first step. This is the second step, and let's say this is the third step. It is loaded in the RAM. Now this, after this RAM, right? Again, okay, not this. This is the third step, right? This is the third step, and from here, let's say it has written in the RAM, fourth step, and from here, right, you would be seeing it on the screen, right? Let's say, okay, let's say this is the part. Similarly, so this requires the use of this. But next time, if you want to read the file again, right, and it is already in RAM, you do not need to go to the hard disk. The operation will look like this: the one, and then it will directly go to this, let's say, to this disk, I mean this operation out there, and from there it will use the RAM. Okay, right? I don't know whether this will be required or not, but since we have to write, I think this will be still be needed, at least on the RAM side, right? But you are avoiding to write in the disk, like directly, right? In that case, right? Okay, this is the read operation, right? So in that read operation, it makes sense. You will start from here. It will get the metadata, and it will come to know, okay, this is here in the RAM. So only two steps are required, from here to here, and then you will get the data. In the write operation, again, it's a different case. Let's say in the write operation, you start again first. So this would be the first step, this would be the second step, and this would write it, right, in the input output operation. And let's say it also maintains it in the RAM. Now if you have to write it again, what will do is, it already knows, like, you have a information in the RAM. So from here, I think it will start from here, and then it will directly go to the RAM and write the items to it. Okay, so you have to understand. And in the end, once you are done, right, it will go and save everything which you have added again in the file from the RAM, right, using this input output operation on the disk which is required. Okay, so this is at the OS level. Now let's understand the Java thing, right? If I have to read a file using Java, what classes are involved and how the operations happen, right? Let's take a case of a text file. Okay, we have a text file, let's say akhil.txt, akhil.txt. Okay, this is our file. This is our file. And what I will do is, uh, I need to see, okay, let me create a file first of all. I have this thing, right? This is our yesterday's work, right? Did I push it? No. Just a second, let me push it. Okay, hit status. Okay, too much to get add. Get. Oh, this is day 26 only, right? Day 26. Yes, day 26. Git commit -m changes, and let's say git push origin day 26. Okay. Now let me just create a branch for today. Uh, hit checkout -b day 27. So the branch is created. Let me close all these tabs, close all tabs, and let's close everything here. So let's delete this. And now let me create a file here. Okay, I'm about to create a new file. I'll create a new file at the root location itself. File, and I will create a file akhil.txt. Today we'll talk about read operations only, right? We'll talk about write operations maybe tomorrow, or maybe when the time is right. But at least we need to know about how to read from a file. Okay. So this is a text file, and let me say, my name is Akhil Jain. I teach full stack as text, right? So let me save this file and let's close this. Now My ask is that I want to read this file, whatever the content it has, I need to read it. Okay, how to do it through Java? I know it through OS, right? How internally things will happen, and it will bring it to me, right? Which is fine. How to read it through the program? Let's start doing it. Let me create a class first. I'll say file demo. Okay. Here, right? What I'll do is let me create the main method. Okay. Now, uh, in Java, right? There are certain classes which you should be aware of. Okay. You remember that file system part, right? Which I've been saying, which is okay. 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 Let ignore that part. Uh, Tell me one thing. In Java, what do we consider everything as? I mean, what ideally we want everything to be like? Everything should be in Java like what? An object, right? Everything in Java has to be an object at the end, right? You create a data type, you create something new, right? It is always an object in the end, right? We have seen this with everything, right? Arrays is an object, string is an object, right? You have now wrappers of your primitive data types which are an objects, right? Everything inside Java is object. Files is no exception. For if you have to work with the file, then files should also be an object so that Java can work on it. Okay. How do you translate your normal file into an object? How do you do that? For doing that, you require a class called file. Okay. Using that file class, whatever file you will provide inside this, right? Java will create Java will create an object for that file. Okay. So that it can start working with that file. Okay. So this is our starting point. So we need to know about the file class. File, okay, which is a part of java.io. Let's use this. File equals to new file. Okay. Now it requires an input. First of all, let me show you. There is a class called file inside Java itself. Java.io. Okay, this is giving the declaration. Okay, no worries. Let's open this. Right. Let me just move it down. This away and here, right? You can see there's a class called file. Okay. Let's start. Let's design the structure of these classes. How these classes look like. Okay. And again, although there are a lot of things to remember, but let's start very simple. We have first thing which you need to do is you need to know about this class. File is a class. Okay. File is a class, and you can see this class in right. Again, what is the purpose of this class? The purpose is to translate a normal file into an object. Okay. Into an object. This is the whole purpose of this file of class. Any file you want to work with, you will have to put that file inside this file object, and then you can start interacting with it. This is the role of it. But let's just try to understand what does this file class is doing, right? You can see it is implementing two of the interfaces. Comparable, I think we remember comparable, right? We have talked about comparable and comparator, so we are not going there. But there is another interface which is used, which is serializable. Again, we have not talked about serializable, and actually we don't even need to know about serializable much, but I will give you some brief about serializable, but not today. Okay. Today, let me edit here, right? Okay, came into the senses. Fine. So this is implementing one of the interface called serializable interface, right? Also it is implementing one more interface which is comparable, right? Okay, this is just for your information, right? I and keep a special focus on the serializable. Okay, that your file is also implementing this serializable interface, right? Now what we need to know is, okay, how do we convert this class in a file into an object? Let's first understand that part. So if you see this class, there are a lot of constructors inside this. Okay, you can use whatever is of use for you, right? But I will use one of those which is very handy, which just only requires the file name, nothing one. This one I will use. Okay, this constructor I will use it only needs to know the path of your file from where it needs to read it. Okay. Okay, fine. How do we provide this? You can see it was a string part, right? String value. So let me get the path of my file. To get the path, right, we have two paths: absolute path and relative path. Absolute path means that from the root directory where it is placed, it will start from there, and it will be the to the path is take to reach that file. Similar to like absolute x path, right. And what is the relative x path? I mean, if we talk about x path, relative is like wherever you're currently placed, from there it tries to create a relation, right? So similarly, for these files also, we have two kinds of complete path which you can identify. If you want to write the complete path, what you can do is right click on it on the file itself, and here you will see copy path. Click on it, you will see absolute path. So you can see it is starting from E drive, Akhil, Podtest, and all that, right? So this is the complete path. Never try to use this one. Okay. Again, similar to like XPath, I have never advocated to use absolute XPath. So here also never use this. Okay. What you need to use is you need to use this one, path from repository root. Okay. Let's use this. I've copied this, and if you place it here, it looks like this because it is placed at the root location. So the path is this only, right? Now this is your file path, right? Now what will happen is by just writing this line, it will create an object of a file class, right, for this file. Okay. So you can understand that this file is now placed inside an object. Just imagine that part, right? You had akhil.txt file, and now it is wrapped over like on an object, right? And this object name is file, right? The name which I gave, this one, right? Now it is ready for Java to be used. Okay. So this is the first task you have to do. Now coming to the second task, right? So this only creates this, right? But using this class, it has a lot of helper methods with you, right? If you want to see, you can see, you can check, is it a file? You can get the complete path of it, absolute file path, right? Is it an absolute file? Okay, this is something else. Path will give you the complete path, I believe, right? Create new file. Let's say you do not have a file with that name, it will create that file. Okay. Can execute. It is checking whether a file is executable file, a readable file, or a writable file, right? You can control it, right? I'm not sure like if you know about this. What you can do is you can mark your files to be either readable, writable, or executable, right? So in Linux, it is. I mean, it is like the first thing which you have to deal with when it comes to reading a file or working with a file, right? But in Windows, I think every thing, right, has all the access, I believe. Okay. If you want to delete the file, right? If you want to check whether it deletes on exit or not, right? Delete on exit. Okay, it deletes on file exiting. Okay, file. You can check whether the file exists or not, right? Let us see this, right? Right, it returns you what? A boolean value. Okay, so try to play with all this, right? Let me just do this. Okay, so if I do this, let's see if this file exists or not. Yes, you can see it says true, right? Let me do one more thing. Let me create Akhil12, right? This file does not exist, right? This file does not exist. Let us see what output does it give. It will return false, right? But try to understand using this file class, I am not trying to read the content, right? And neither I am trying to write the content to it. I'm just trying to do some operations with respect to the file existence. I'm trying to check whether the file, I mean, some meta operations, right? I'm trying to see, okay, is it executable? Is it readable? Is it writable? Does it really exist? And let's say if I have to create a new file, how to do it? How you can do it? Let's say you can see, right? It says false, right? And you can see the file does not exist. Let's say now there is a need, I want to create a file. You will start like this only. You will give a class file name to it, whichever you want to create. But after that, what you will do is you will say file dot create new file. Okay, create new file. It will do that. Okay, let's see what it says, and add exception. Okay, try catch, right? create new file. Okay, and once it will create the file, I will then check whether the file exists or not. Okay, but again, not reading the file, not writing to the file, it's just creating a file, right? But again, I'm saying just doing this will not create the file. If you have to create a file, you require this thing. Let me run this. You can see, right? It says true, and you can see the file is created. Okay, right? Again, I'm saying by just doing this, it does not create a file for you, right? It will just create an object for that file. And if you really want to get a file, use this method, create new file, right? Similarly, if you have a rate, if you already have a file and you want to check something about it, whether it is readable, writable, executable, whether the file really exists, right, and all that. If you want to get the absolute path of it and all that, right, you can use this file object. You will have the methods, right, which you can do. Let's come to our actual need. We want to read from a file. For doing that, what we really want, right? So this is the file class. So its job is to convert your file into an object, which is the first step in your reading process also. So if you have to read a file, what is the first step? The first step is, let's write it here. If you want to read a file, what is the first step is? Create the object for your file. Create the object for your file, which we have done, right? We have already done that. Now the second part. And this was done using which class? File class. Okay. I've done that. And we have seen this is the structure of it. Now, if you have to read the file, okay, you need to know about this class now. So do you require a separate class? Okay. What is that class? The class is this, file reader. Mind you, we are currently talking about reading the file. Okay. We are not talking about writing into the files. Okay. So keep that portion for some other day. We're just talking about reading the file. Okay. File reader. Okay. Let us go to this file first. I mean this thing, and let's try to understand what does this class looks like. You can see this is a file reader. Okay. This is a class, and it is extending one more class, which is input stream reader. Let us try to create the mapping of it. So you want to read the file, right? So for reading of the file, what I'm saying is you need to know about this class, which is file reader class. Okay. And this class is implementing, right? This is extending, sorry, this is extending. So there's a parent class for this, and the name of the class is input stream reader. Input stream reader. Let us also check what is the hierarchy of this class. Okay, this class is implementing one more class which is called reader. Okay, so this is implementing one more class called reader. Okay, so this is a class, right? Now you see this thing, right? Input stream reader and file reader, right? And we will be using both of them. Okay, remember, whenever you see this word stream, right, anywhere, whenever you see this word stream, right, try to understand it has a relation to bytes. Okay, it has a relation to bytes. So whenever you see streams, it has a relation to bytes. Okay, and wherever you do not see stream, right, there it has a relation to character. What is a byte? What is a character? Although we have learned about this in the data type chapter, but let me revise it. Okay, and why it has to be only these two? I'm coming to that part also, right? So, and why? What is the purpose of these two classes? Okay, so let us start exploring these classes a bit. Okay, not very in depth. We will just understand the methods which are of use for us, right? Nothing else. Okay, let us first start from this class, which is the reader class, which is the last class, I believe. Oh no, reader is also, it's an abstract class first of all, and it is implementing readable and closable, right? But these are interfaces. So let me write it here. It's an abstract class. It's an abstract class, and it is implementing two interfaces, readable and closable. Okay, closable also, right? Closable is uh, a very important interface, right? We'll talk about it. and readable again, right? These are two, but we do not have to go inside them. But you have to remember, right? There is a class, there is an interface called closable, which is fine. Now let's go inside the abstract class reader and let's see what does it have. But again, it's an abstract class, right? So you cannot create the instance of this class. So, right, if you have to use this class needs to be extended by someone, right? Because it's an abstract class. An abstract class cannot be instantiated, right? As per the rules of Java, which we have learned, right? So similarly, here you can't do it, that part here. So, so for this class, at least you cannot use it directly, right? You cannot use it directly. That's why you have a child class which is implementing this class, right? Which is extending this class. And if you want to read a file, you can either use this one or you can use this one. Okay. Now let's understand this part first, right? Because it will bring a lot of clarity now. If you have a file, if you have a source, see everything when you, let's say, let's understand, right? What kind of files you have seen? You have seen a file .text extension, which is a normal text file, right? Similarly, you have seen an .xlx file, you have seen .docx, right? Or doc file, maybe .pdf file, right? These are all what? These are files which has some content, right? Some alphabets or alphanumeric things inside this, right? Everyone, and this is what we want to read, right? This is like the text part. This is like a text part. Now there are some other kinds of files, right? Let's say video files. Do you have the content written there? Just a second now. Okay. Right. So what are the other kind of files? You can have a image, right? Dot jpeg file. Let's say a mp4 file. Okay. Let's say a mp4 file, right? The audio file, right? Video file, audio file, image files, right? So there could be multiple things, right? So why I'm telling you all this is because you can categorize your files under two things, right? One which will have some kind of text inside this, right? Which you want to really want to read. Some other files which does not have the text which you are concerned with, but it's a different kind of a file which achieves something else, like an image, a video, or an audio, right? So for that reason itself, you have two different kind of ways to read from a file. Okay, if your file is like a text based file, right? If you have a text based file, ideally what you should do is, I mean, not ideally, I mean, the for these kind of files, what is the example? Let's say talk.txt file, .xls files, .doc file, right? .pdf file. For these files, right, what you can do is you can use the approach of reading character by character. Okay, let's say I have written my name is Akhil Jain, right? So there the first character in that file is M, right? M. Okay. And how this reader thing, right, works is it can operate in two different ways. Either it can read the content as a character, one character at a time, or it can read bytes by bytes. It will read one byte, then the second byte, then the third byte. These are the only two possible ways to read the content from the file, either in the way of a character or in the way of bytes, right? Now, right, so using the reader thing, right, you can read the content or consume the content as a byte or as a character. Okay, and these are the only two options, right? Now, if that is the part, like which class helps us to achieve what? If your intention is that you want to read character by character, okay, then you should use this class. So if you want to read character by character, you should use this class, right? If your intention is to read byte by byte, you should use this class. I hope this is clear now, right? Why there are two classes. Okay, and I told you to just to remember like how things are. Stream signifies that you want to have the it's about the byte part. Okay, it's about the byte part. But here trying to understand is, let's say again, if we understand it here, right? You have an OS, you have an operating system where the file system is also involved, and your file is there in the disk, right? In the disk, in the hard disk, right? If you use, and I also told you there's a concept of a RAM, right? RAM, a memory part, right? If you use these two classes, right? What you are what you are actually doing is you are asking your OS, right? You are instructing your OS to read the next character from this file, which is placed in the hard disk, right? So if you use these two classes, it will not make use of RAM. It will not. Okay. It will not make use of RAM, or at least, okay. Consider this statement to be true as of now, right? And try to understand, if you use these two classes, it will not go inside the RAM. I mean, it will not make use of RAM. And let's say my file over there, right? Let's say akhil.txt file has almost, let's say, 10,000 lines of code. Okay, let's say 10,000 lines of content inside this, right? And every line has hundreds of characters, right? So it is like 10,000 lines, and every line has what? 100 characters. So how many characters we have? I think 1 million characters, right? 1 million characters. Okay, in just a single file. Okay, and I am saying that I will read it character by character, character by character. So try to understand the kind of load I am putting on the system. I am saying to my OS, please go inside this file and get me the first character. Okay, it will go inside the file, get me the character, the first character, and it will place it with it, right? Then it will go and find the second character and place it here. It will keep doing it how many times? 1 million times, considering the whatever you had there, right? 1 million times. And try to understand the load which you put on the system. You are just doing this part. Your disk input output disk needle, right, is continuously doing this, right? It is like fibbling, right? It is doing that part. Okay, now I will write this, now I will write this, now I will write this, right? It will keep doing that part, right? And you are touching your hard disk with every operation. Okay, okay, fine. Now the second part, uh if this is true, right, I've seen, right, in this case you're not using RAM. How better it was, let's say this file, right? This file, let's say, first of all, we need to improve, right? First of all, what we need to do is we should not be reading character by character. It should be like a block of characters, right? If because a single character when I'm reading, right, this requires a lot of operations, to and fro, a lot of to and fro, right? I don't want to do that. If I don't want that, right, what I need is I want to read a block of characters at one time, not just a single character. So I need to read lot, I mean more characters, right? More characters at a single time, right? At a single time. So this is one need, right? The second need is the second need is that the second need is that, I mean, just to achieve this, right, it should also make use of this RAM, right? RAM should be used. Okay, this RAM portion should be used. Now both these things are not achievable through this. Okay, these are not achievable through this. If you have to, and the right word for this in Java is we have to buffer. We have to buffer or cache, right? Or cache it, our content, right, into the memory. Okay, and that to a block of content, right? Not just a single character. Okay, so if your need is that you want to read, right, you want to buffer the lot of data, right, together, so that, see, if you read, let's say, 8,162 characters at a time, right? Let's say that is the size, that is how you can store in the buffer, right? Let's say I create a buffer here in the RAM like this, right, which has a size which can store 8,162 characters at a time, right? So what I'll do is, using this, what I will do is I will read 8,162 characters from this file first and place it here, right? And then I will, it will be like I will be used as the user, right? As an end user, I will be reading through this, right? So to read this data here, right, it did what? It just used one operation, right? It just used one read operation. one read operation. Whereas just to read the same number of characters, I had to do how many operations? 8162 operations just to read the same number of characters, right? From here to here, right? Try to understand how much saving you're doing, right? If you start using the buffer part. Okay. So this is one operation. And from the RAM, if you have to now access the data, it is much more, I mean, much less time consuming, right? It is very quick, right? And it does not put a load on your disk also because it is in the RAM, which is very fastly accessible. Okay. But if you want to make use of RAM, these two classes are of no help. You need to use some other classes. Let's see those classes first of all. Okay. I'm just telling you about different classes. We will see like how to use of them, right? How to use them. Or let's first use without the RAM part. Okay, let's try to do this. Now I have created a file object, which was my first task, and now I want to read the content, right? What should I do is I want to read character by character. I will do what? I will create the instance of file reader, okay, and I will give it a name file reader, new file reader, and this file reader. Let's go inside this class. If you go inside this file class, right, you can see it has different constructors calls. The one of the constructor call which is of importance for us is this one. You see this file? This constructor is asking for the file which you want to read. Okay, this is the one, right? It requires the file input, right? Now, what is the object which I? So the first step was I converted my file into an object, and this is of what type? File type, right? And this is exactly what I have to provide here. Okay. Now it will have to manage the exception. So let me put it here, right? Now, so now it can start reading the file, right? Let us see what are the methods it has. Sorry, it has to be block scoped. So fr dot. Okay, you can see there are certain operations, right? Again, you don't have to understand everything here. We will use this one, right? This to read the data from the file, we will use this method read, right? Okay. Now, how does it work is I told you, right? This file reader reads what? Let me see it here if I can show you. If it marks here, reads text from characters files using default buffer size, decoding from bytes to characters using either a specified character set or this file is meant for reading streams of characters. Okay, it reads streams of characters. Okay, fine. It reads streams of characters. Okay, I'll improve on this understanding here, right? But just try to understand and focus this part, right? It reads characters. Okay, read characters. Fine, right? It reads characters. So, okay, where I was, not here in the code itself. If you go here, right, the purpose here is we want to read characters, right? So if you have the intention of this, you should use this one. Okay, if you are reading the character, right, you need to store it somewhere, right? You have read the character, it should be placed in somewhere, right? Right. What is the kind of output this read method will generate? This read will be reading the file and bringing the characters, right? And this will be like a block of characters, and you need to store it, right? Where can you store characters? A block of it in a
String.
character array. In a character array, right? It's not string as of now, it's just character by character, right? I did
Okay.
not set strings, I said about characters, right? There are only two modes. Either it reads characters or it reads bytes. Okay. You may think, okay, a stream of characters is like a string, but that is not how it works here. It is on the data type, specific data type, right? It is reading character by character. Okay. Now what is happening here is you need to have something here, right, where you can store all this. So what is the right place would be? The right place would be to create a character array. Let me create it. Character file, right? Let's say equals to new. Okay, it has to be small c character and new char. And when you are creating a character, you have to give the size, right? Let's say this one. Okay,
How would you know how many characters are there?
I don't know. I don't know, right? As of now, I don't know. We will
Okay.
try to see that, right? How to solve
Okay.
that problem. But as of now, I have given any number of characters I want, right?
Okay.
So I've done that. Now what I need is how this read method works, right? It needs to know the place where it needs to store the information, which it is getting from that file. So if you would see this, right, constructor, I mean, let me write it again so that you can see the, okay, there are different overloaded versions of the read method also, but I want to use this one, right? You can see it needs an input of character array type, right? And what I'm saying is I have created this below one to store the red characters, right? Character data. So I need to provide this as an input to this read method. Okay. And I think this will also require the handling of more actions, add catch process, right? Now this is good. Okay. So again, try to understand. Let me repeat what I've done, right? The first thing which I have required is I need to create the file object for that file. Now the file, normal file got translated into an object. Okay. Now the second operation is required is I need to read from the file and I want to read it by character by character. So what I should do is I should use this file reader class. Okay. And when I'm writing this, I will provide the file object, right, which I've created above. So this is the first line, this is the second line. Right. Now the intention of doing this to read the content, right? And there's a method called read on this file reader, which I will use. But as an output of this, right, I need to store everything which I'm reading into a source, right? Into a place. So for that, I will store it into a character. And why only character? Because this provides me an output as characters only, right? That's why I have to use character, right? Okay. Does anyone remember if we talk about data types, let's say character, right? How many bits a character uses in the memory to store the data in Java? Do we remember? Or at least do we remember about int? If I create int I equals to 35, how many bits of memory it will take in Java for storing that? 32 bits. Okay, it takes 32 bits. And for characters, it takes 16 bits. What is a byte? Byte, one byte equals to 8 bits. One byte equals to 8 bits. So you can say one character is equivalent to 2 bytes, isn't it? We can say that, right? One character is equivalent to 2 bytes, right? So remember this thing also, right? What I'm saying is one character, right? If I say you to save one character, right? It will take how many? If it is again, it also depends on the encoding scheme. Let's say I am using an encoding scheme of UTF, UFT or UTF. I think it's UFT, I believe, or UTF. I don't know the coding scheme, right? It uses UTF-16, so it will use how many bits? 16 bits to store that single character, and we have already learned 1 byte is equals to 8 bits, right? I hope I'm right on this, right? So what it also means is, so if I talk about this normal part, one character is almost equivalent to what? To 6 to 2 bytes, right? Okay. And here try to understand we are reading character by character, okay? Not bytes by byte, right? So this is reading character by character and I'm storing it here, right? So I have read the content, right? I have read the content of my file here. Okay, fine. Now let's say I want to print what I have read, what I have written. So what I should do is I should do this thing. This is an array, right? And now this array holds all my data which I have read. And how do you skim through an array? Using enhanced for loop, I can do that, right? So I'll say this for character C character file file, and I will print what? I will say print C. Okay, I will do this. And once, see, I told you, right? If you go back right here, file reader. If I show you this again, right? File reader is extending this reader class, right? And this reader class is implementing this closable, right? So because of this closable part, right, what it means is, see, what is internally happening is it is making use of operating system again, right, internally, to get the access to that file which is placed somewhere, and it keeps I mean something, a thread, right, on it, to keep it open, right? So if you are reading through a file using Java, right, that is the operation which the OS takes. It opens that file internally somewhere, right, in the memory or somewhere, right, so that you can read the data from it. So once you are done with your job, always make sure to close that connection which you have opened up with that file. Okay, and to close that file, right, to that connection, that's why this closable interface was implemented here. So because as part of this closable, you get access to one method which is called as close. So you should do it on the file reader, right? So the file reader thing has a close method. So always make sure once you are done with the file thing, right, close that connection, and you close that connection by doing fr.close. Okay. Now let's run this and see our output. Right. Let's run this. So I should be able to see this is okay. I did not change the content, right? Let me run this. And mind you, we are reading character by character. Let's see the output.
Uncle, one doubt.
Yeah, please.
Actually, the format, why is it UTF-16? We usually
Yes,
use 8, right?
it is usually 8.
UTF-8, I guess that because, like, not sure. There is ASCII, there is UTF-8 and 16, right?
Yes, but
I
I think for ASCII we use UTF-16, right? I believe. I mean,
no,
I
there are
don't remember
three.
exactly.
No, no, actually, I thought maybe for Java, do we use UTF-16? That's why I had a doubt. Or we can use anything.
See, there is a default way which you can use, I believe, right? Either I am. Let me check. Actually, I'm not very 100% sure. So let us check it here. Uh, UTF encoding used for for characters characters in Java. But again, it does not matter, right? Even if it is UTF-8 and if it uses 8 bits, right? Okay, it says UTF-8. It is the most common use in the present time. Okay, it uses 8 bits to encode the variable bit. Okay, great. Then I'm wrong here, right? So I think UTF-8 is the one which Fizula is mentioning. Okay, so in that case, one character is equivalent to that 1 byte. Okay, fine. If that is the format which you are using for the encoding purpose, right, by default. But if you switch to UTF-16 to store your data, or UTF-32, right, these many bits would be used to store the data, right, Fizula?
Yeah, yeah. Actually, what came in mind is now when I do the automation, the backend part currently, so
Mm-hmm.
UTF-8 comes from the backend. The developers have developed in that way. So that's why it just clicked my mind.
No, you're absolutely right, and thanks for mentioning this also. So for UTF-16, right, it is 16-bit, and if we do it for UTF-8, it is 8 bits, right? It is 8 bits. Okay, so in at least so for this, if you and this is the default way. This is the default way. Okay, and if it is the default way, in our case at least, one character or 1 byte means the same part. Okay, at least the kind of data which you will be reading. But try to understand the, again you will see the difference here, right? I will show you the difference, but try to understand, you are reading what you have written there, right? This is appearing as is, right, what you have written there in that file. Okay, now we are reading by character. This time we will try to read bytes by bytes. Okay, and see the difference in the output we will see. Let's read it. See, in the end, what happens is, you have to understand, right? In the end, everything goes and to get stored as a bit, right? As a bit, right? Whenever this character would also be stored in the memory, it would be in the form of bits only, right? Not like A, B, C, and D, right? Not that like that, right? It would be like numbers 0101, right? A 8-bit thing would be stored for that specific character, and then it would be read, right? And then it would be translated back into a character. See, what I'm saying is this: in we have although we have covered this, I'm just repeating myself. If you say this, right, character, let's say character ch, right, and you say it as a, and you store it, what does it really do, right? It will see, it's a character for you which you can see right now, but in the system, right, it will not be stored as a, it will be stored like an 8-bit information in the memory, which will be like 1 0 whatever that value is, right? I don't know, be like based on the ASCII value, but let's say this is the value which gets stored in the memory. This is something stored in the memory, right? So in the end, it's only a bit. So if you are writing it, it will be stored like this. And if you are reading it, right, if you say that read me a value of this character, it will go to the memory, read this byte, right? It will read the byte, but to show you the output, right, it would convert this byte into what? Into a character, right? So that conversion will be happening, and that's why you are seeing character, right? When I'm using character, I'm seeing that output like I am Akhil Jain and all, right? Because the conversion was happening here in that case. But if I start using bytes instead of characters, what kind of output I would see? Let's see that. Let me do one thing. Let me just grab it and let me grab everything and create a method like saying it is a public void read data from file, read data from file as characters, okay, as character, okay, without using buffer. Okay, very lengthy name for our method, but fine. I hope this will bring a lot of clarity, right? So this is the method which we created, right? So using this method, you will read the data from a file as characters, but without using buffer. Now let us create a method which will read, which will do almost the same operation, but as bytes, not as characters, right? Let me grab it again and let's just put it as is on top, right? And let me just remove the unnecessary code, which is this file, right? I don't want to create this. Okay, so this is there. So it will read the file, and here, right? Now I want to read what? I want to read bytes. If I want to read the bytes, I should not use this class. Okay. Okay. Is that really the case? Let's see that, right? If I want to read the file, let us write, what was the name of the class which we were talking about? File input stream or what? This was file reader was input stream reader, right? Input stream reader. Let's use this input stream reader. I hope that is the file to read from it. Okay, okay. Okay, okay. I think I'm telling you one thing wrong. This is not the class which will be used to read from it. Uh, okay, okay. My bad. Okay. There is one more class which we should know, which is file input stream. Okay. I always get confused in this part. Just a second. File input stream. Let us see at this file, right? What is this class? If you look at this class, right, this class is extending one more class which is input stream. Okay, let us see this class. This class is implementing closable. Okay, fine. File input stream and this, right? And if you go inside this class, okay, file input stream, right? It needs file input only. Okay, fine. Okay, okay, right. File input streams. Okay, okay. So over in this part, right? When we were discussing this, let me correct myself on one point. Where is that file? Here, right? Here, right? This will not read by okay. This will not read. We have to learn about another file input stream. Okay, file input stream. Okay, this is the class which we have to learn. if you want to do the operations by byte by byte. Okay, byte by byte. This is a different class. And this class over here, right, implements one more class, which is input stream, I believe. Input stream. Okay. Input stream. Right. Let me just double check myself again. Reader class, file reader. So this readers characters and reader reads byte. Just a second up. I just want to be sure. File input stream is one class. It is a part of input stream, and file input stream. Okay. Okay. Yes. Yes. Okay. So again, right. So this is for the characters, right? This is for the characters, and this part is for the bytes, byte by byte, right? Now input stream is a class. File input stream is a class, is an abstract class which is implementing another one interface called, it's an abstract class, and it is implementing closable, right? And it's a interface, right? Okay. So just remember again, right? If you are to read the characters by characters, this is the class you have to use. If you have to use bytes by bytes, this is the class you have to use. Okay. So this is for bytes by byte, this is for class, right? The same operation, right? How you did for file reader, what you did was you created the instance of the object of your file class, right? I mean, for the file you created like an object, and you passed that object to this file reader. Similarly, the same operation is required in this case, but just that use this class right now. Okay, file input string. So let me remove this. Okay, let me remove everything. Let us write it again. It will reduce my, I mean, it will help me to write it in a clean way. File input stream, okay, FIS equals to new file input stream, and I need to provide the file object to it, okay, file object to it, which represents this file. Now I need to add the try catch block, file not found exception, and this is done. Now this will read my file. Okay. Now let us see the methods which this file input stream has. If you look at this, right, the same method, read method, right, like how it was there in the case of byte, in the case of characters. But this time you can see the input it needs a byte array so that it can store those bytes which it is reading, right? So how it will do it? We will do what? We will create a byte array. Byte. What is a byte? If you remember, byte is a part of integer family, right? And integer family starts like it has four things: byte, short, I think short, sorry, short, byte, and then it is int, and then it is long, right? That is how the family of the integer looks like. So it's like an integer value, right? So byte is like an integer, right? If you understand that concept of integer family, it has four things inside this: byte, short, int, long, right? And byte is one of those parts. Okay. So let's say byte character. Okay. Byte array, let's say, right? And I will say new byte, and let's say give the size of this time. Try to understand here, right? A single character, right? A single character over there uses, let's say, 8 bits, right? So I have so many characters there, right? You can see how many characters I have: 1, 2, 3, 4, 5, 6, 7, 8, like almost like 20, 50 characters. And for every character, if it takes 8 bits, so multiply it by 8 at least. So if it is 20, at least 20 into 8, 160 bytes, 160 bits, sorry, right? You need 160 bits. it is in bits again, but since it's a byte, again, it is like similar to characters, right? 8 bits, 8 characters. So let me give it a size of 50 again, right? 50 only. Because as per our, as we seen, we are using UTF-8. So one character represents 8 bits, right? So if we provide an array size of byte as 50, so every byte would be able to store one character. So I think this should be sufficient. Okay, fine. So this should be sufficient here. Now we need to provide this byte array as an input to this read method. Okay. And we need to add the catch block for this. We did that. Now to read the content, right? Now I want to print the value similar to like how we were doing it in the character operation stuff. We will use the for and we will say and byte array. See what it will print. I will print what? I will print B. Okay. And in the end, once I'm done with all my operations, I need to close my file. Okay. So this is done here. Let's just run our code now and see what happens. Last time when you ran, you saw this kind of an output. Let us see what kind of output you should see now. Will it be same or different? Oh, it's not same, right? It is showing me bytes. It is showing me the bytes, right? Okay. See, just try to understand what is the purpose here, right? In the first operation, you did not wanted to do that. I mean, you wanted the actual output, right? And you had a text file there, right? In the text file, the actual output is based on the characters, right? And you really wanted to deal with them. Okay. You do not care how they are stored internally by the system and all, right? What you cared is that you wanted to read what you have given to it. So if that is the purpose, you should use that, the character thing only, right? But if you are okay to, I mean, to get the response as the actual values which are stored in the system, like in the form of bytes, and you are okay to use them, you should use this. And this will make a lot of sense when it comes to storing a image, a video file, or an audio file, where you do not store it like a character. You store some information, right, which is like an any special character or something, right, inside this. But even that information, right, what that file may contain, if you try to open a mp4 file in a text editor, right, you will see some garbage, right, which you will not even understand. So right, you will not understand that file, so it does not make any sense for you to retrieve it as is, right? What makes sense is that you can get, I mean, for all such things, right, what how industry works is they use bytes, right, and maybe some other data types, but not the characters. Okay. So if you have a file of let's say you would be working on taking screenshots in your automation framework, right? You need to take a screenshot and save it somewhere, right, inside your file, like a jpg file. And now you want to read that file and maybe place it somewhere else. How you should read it? You should read it I like a byte, not as a character. Okay. And if you want to work with let's say a text file, right, like this, so in that case you can directly use the character thing, right, not the byte part. But again, no one stops you to use this byte part, because this also can be translated into characters. How? Let's see this. I will convert this bytes into characters and see the output now. What does it really show? You see this? I have converted it into a byte, and now I'm reading byte by byte. Let me convert this. When I'm printing this, right, I will not print the byte, I will print the characters. How? I will convert every byte into a character. Okay. How will I do it? Let's say I will create a character a equals to a, let's say, right? Let's say, or ch here, right? Ch as this. And what I will do is I will say ch equals to casting, right? I will use the cast operation and I will convert this b into a char. Okay. And I will print this. I hope this is making sense, right? I'm just converting a byte into a character, right? And then printing it. Let's see what output we will see. Will we see this, or will we see the same output as we were saying in the case of reading by the characters part there? Okay, let's run it. Eureka, right? We got the same output. So it means whether you read as a byte or as a character, right? In the end, it is up to you, right? How you consume it, right? That is the whole part. Okay, right? So try to understand, if you have both kind of files, right? Say character and let's say an image file. Okay, a content, a text file and an image file. A image file cannot be read like a character. Okay, it will not make any sense for you. So for those files, byte is, it is mandatory, right? That you should use byte there. Fine. But in case of the text file, you can use either. You can use a character based format to read, or maybe you can use a byte based format. So if you look at the overall analysis, it means that it is better to use to read the content from these files like a byte. Okay, because if you have written a utility to read from a file as a byte, you can work with any kind of files, be it an image file, video file, or anything else, right? A text file or something, right? So you will see in a lot of places that people are reading the content through bytes only. Okay, not as a characters. So you will see this command more, right? Like a file input string. But you have to understand like what is really happening behind it, right? You have only two ways to read the content, one as a byte and a character, and there are two different classes to use for that, for those operations. Okay, and this is how you do it. Okay, let me just rewrite what we have learned today. So what I'm saying is, first of all, you need to know about the file class. Okay, if you want to work with a file, create the object for that file, give the path, the complete path of that file, absolute or relative, whatever you think is right, just give it there. It will convert that file into an object, right? If you want to read by character, read characters, right, you should use which file? You should use a class called file reader. You will create this file reader, new file reader, and provide this object to this, right, file. And you have a method called read here, and here, right, you need a character array so that you can store whatever you are receiving array, right, like this. So new character, let's say 50, right, size of it. So you need to provide character here, right? So whatever you would read from this file would be stored in this character, and in the end just close this file. That's it, right? The file is read, and then you can use the enhanced for loop to iterate through this array to read the content. It will be read as character by character. Okay, if you want to read by byte, the same operation is required. Just this time you will use which class? You will use a class called file input string. File input string, new file reader, file input string. And here also it will require what? It will require the access to your file object, which is this. And you will do the same stuff, file dot read. And here this time you will provide, sorry, byte bd equals to new byte, and let's say 50, right? And here you will provide btr, and you will fis dot close. Okay, so this is what you will do to read a file. As a character is this, as a byte is this. But the first step to start is to convert your file into an object like this. Okay, I think we are good for today. I don't want to cover something else, but try to understand. We have not used buffers. We have not used buffer today. We have not used buffer or cache today, right? We will use this tomorrow, okay? And try to cover this part tomorrow, and we will see like how this read operation can be completed, right, by using the buffers part. Okay, but this is how you read a file. For writing a file, I will hold some separate sessions. We will not cover it currently because when it will come to our automation framework part, right, our objective is more on reading the content, right? We want to use it as a test data source and store it somewhere, right? I mean, and consume it from somewhere, right? So that we can use it as a test data source as an input to our test cases. Okay, so we will see how to do that. I mean, for all of that, right, we require this knowledge plus the knowledge which we'll gather tomorrow about the buffers and cache, right? So try to understand my planning. What I've done is we have covered the threading, which will help us to achieve parallel execution in our automation framework. We have covered this part because we wanted to read the data from our files, Excel files or some other files, right? And we need to know about all this. So that's why we have covered this part. One part is pending buffer cache, which we will cover tomorrow, and which is the preferred approach to work with the files. Okay, this is not the preferred approach. We will learn that tomorrow, and it's very simple. Okay, it's very simple. It is just in the continuation of it, and we will learn that. And once we are through this, only part is pending would be the date time system. Again, date time system, it may or may not be required while working with the automation framework, but it does give you an advantage to work with and with any dates, right? If you want to have, let's say you are reading a date from a website, right, and you want to find whether the date is correct. Let's say you want to do some operations based on the date, right? You should not be doing like yourself adding some new logic, right? There is already a package inside this Java, right, which helps you a lot in doing all of that stuff. So we need to have good understanding around it. So we'll build that understanding, right? But for tomorrow, for this week, the only topic left is buffered cache, and that to the read operation, not the write operation. Okay, we'll cover it tomorrow. And one last thing, tomorrow, right, I may not be able to take a class in the evening again. So let's take a class in the morning itself. I'll not take much time. It's just a 1 hour session. Okay. So we'll start at 8 and we'll try to wind up things by 9. Okay. I'll not take much time tomorrow. So because we have already covered the basics of it, so we should be very good. And please spend whatever time you're left in this week on completing the Selenium assignment, right? The next assignment which I've gave today is like once you create all those three end-to-end scenarios, right, using Selenium, please try to run them in parallel mode using the concepts of threading which we have learned yesterday. Okay, try to create 3 threads and run those 3 test cases as part of that, right, by giving them their individual WebDriver instances. Okay, don't make use of testng. I don't want anyone to use it, but these are 2 different assignments. Okay, first try to complete the Selenium one and then move to the testng, the parallel execution part. Okay, I think we are good for today. If anyone has any doubt, please ask. No, great. Let's meet tomorrow, and I will just edit the invite and send the invite for 8 a.m. morning tomorrow. Okay, and we'll cover the way. Yeah, Fizla, please.
Like you kept repeating, right, not to use testng. I mean, I'm completely beginner to that. What is the main advantage of using it? And if in case we're going to study testng, like people will be using that way, right? A file execution compared to a Selenium
Yes,
one.
yes. You are absolutely. See, first of all, Selenium does not provide you any parallel mechanism. Okay, Selenium does not provide. What provides is the Java, right, which we learned yesterday. So what I'm saying is, and and just to answer your question, right, the default way for us as an automation engineer to achieve parallel execution is we do not have to implement or re-engineer anything new, right? We don't have to do it. TestNG already has the capability inside this, which will help us to run our test cases parallelly, okay? Which we can do it. But what I'm asking is that since we don't know about TestNG yet, right? But we do know like how using Java we can create multiple threads, right? And run our things parallelly, right? We learned it yesterday. So what I'm saying is using that concept which we learned yesterday, try to create 3 threads and assign all your 3 different test cases to these 3 threads, okay? And try to do that execution. This is what I'm asking, right? This will help you to, I mean, solidify your knowledge around threading, which we learned yesterday, and especially about thread local class, okay? Because that is the portion which will be required in the TestNG also, right, Fizula?
Yeah, I got it. Okay, thank you.
Yeah, okay, great. So these are the 2 different assignments, right? One completing the Selenium one, and then implementing the concepts of uh, threading, right, on that assignment, so that all 3 test cases can run parallelly using 3 different browsers. Okay. Okay, great, everyone. I think we are good for today. Let's meet tomorrow morning, and I'll update the invite. Okay. Thank you so much for joining. Bye bye. Good night.
Thank you. Bye-bye.
Thanks,
Bye.
all.
Good night.
Good night. Bye.